So what we're going to be doing today is I'm going to be drawing out your discussion question so that you can see how muscles contract. So what I'm going to do is I'm going to suggest that you get a piece of paper. You may want to grab a couple of different color pens or color pencils to kind of color code some of this. So we're going to start right here and just kind of quickly talk about the neuromuscular junction. So the neuromuscular junction, I tell students that this is really kind of the electrical part of this whole process. So that's an R. So what happens is you have this muscle fiber that looks like this, or muscle that looks like this. And attached to that muscle, you're going to have this structure that looks kind of like this, and that is known as a motor neuron. And a motor neuron is connected to our nervous system. So when our brain says, contract your arm, that message, contract your arm, comes down that motor neuron to our muscle. So what I want to do is I want to blow this up and draw it bigger so that you can see it a little closer. So when you look at a muscle fiber and you get kind of close to it, you see that it looks something like this. So this is the muscle fiber. And this is the motor neuron or motor axon. Okay. This is our muscle. Okay. And this little space right here, this is called the synapse. It's the space between the motor neuron and the muscle fiber. Okay. So what happens is when our brain tells our arm to contract, that message comes down this nerve, okay? So this is our action potential, okay? Because it has the potential to create an action, all right? When the action potential gets to the end of our motor neuron, in this little synapse, there are these tiny little vesicles, and there's thousands of them, but we're not going to draw thousands. There are thousands of them filled with acetylcholine, or ACH. So when the action potential reaches the end of this motor neuron, it triggers these acetylcholine vesicles to release the acetylcholine out into the synapse. And the acetylcholine allows sodium, which is all in our body, but there's sodium ions, little Na+, all in the synapse. When the acetylcholine's released, now sodium can diffuse in. And this is going to happen all down the muscle. Lots and lots of sodium all the way down. And we're just going to get tons of sodium. Okay, so that's good because this action potential, when it gets to the end of the motor neuron, it doesn't stop. Instead, what happens is it continues along the membrane of our muscle fiber. Okay, that membrane is the sarcolemma. It's able to do that because it follows this little electrochemical gradient that's produced by the sodium. And on down here somewhere on our muscle fiber, you are going to find this little, almost like a rabbit hole, that is called the T-tubule. It is part of something known as the T system. And it ends right around a structure known as the sarcoplasmic reticulum. And inside the sarcoplasmic reticulum, you have lots and lots of calcium ions. So when the action potential comes down the T system, it triggers the release of calcium. So calcium is going to diffuse out of the sarcoplasmic reticulum. Now remember, when calcium levels go up, now our muscles can build a cross bridge, and that is going to pull and shorten the muscle, okay? So calcium causes the muscle to build a cross bridge and begin to contract. Okay, so this is our electrical part, this is our chemical part, this is our mechanical part. Okay, so when it's all said and done, we of course want our muscles to relax. So to relax our muscles, acetylcholine esterase breaks down acetylcholine, and calcium ATPase pumps calcium back into the sarcoplasmic reticulum, and then the muscle relaxes. Okay, so one more time. Our brain sends the message in the form of a nerve impulse, we call it an action potential, comes down the motor neuron, triggers the release of acetylcholine, which allows sodium to diffuse in all along the muscle. The action potential continues all along the sarcolemma till it reaches a T-tubule in the T system, which terminates at the sarcoplasmic reticulum. Sarcoplasmic reticulum releases its calcium, which causes our sliding filament model to happen. So the thick filaments bind with the thin filaments, building a cross bridge, and the muscle begins to contract. When it's time to relax, acetylcholine esterase breaks down the acetylcholine, so that stops the influx of sodium. Calcium ATPase pumps calcium back into the sarcoplasmic reticulum, and the muscle relaxes. One other thing right here that we need to make sure we put: potassium is pumped in, so that way it can pump that sodium back out. Okay, so definitely go back over this, and I would definitely watch the video one more time that goes through the notes. If you have any questions, feel free to email me. Thanks.